Thank you, Chris. So I will be the first speaker today, and I will be presenting how we do AI at Datadog, basically focusing on how we build a platform to build generative AI application at Datadog. So before I start on this topic, I want to present a little bit what Datadog does. So Datadog is an observability and security platform. So basically, when you have an infrastructure and you want to monitor what it does, monitor if there's any alert, its performance, you can go to Datadog for that. And this is like for your whole infrastructure, the security and the observability of your platform will be handled by by Datadog. So we are distributed all over the world. This is the Paris office, and the Paris office is celebrating 10 years this year. And we will be, after these talks, we will be there, like you can come and talk to us. Like there will be people that will have some badges that are for Datadog. If you want, you can talk to us to understand what Datadog does and to understand more about us. So specifically, I'm Sarah. I'm an engineering manager at Datadog, working in the department of AI platform. So AI platform specifically is working on providing tools and solutions for our AI engineers that build products, and specifically AI products, so they can accelerate the innovation in the space. So what do we have as data at Datadog? We can have infrastructure data, application, real user monitoring data, some security signals, logs, and metrics. And all this data, we can come up with application and products from it. So through AI, through doing some machine learning with this data, we can come up with some findings on your infrastructure, come up with some patterns, do some recommendation to say this is the best way to monitor or to go about an alert. And specifically, I wanted to share some of our products. This is not the full suite of our products, but these are the ones that are AI specific. So Bits AI, for example, is a generative AI-based copilot. So if you want to investigate your alert and incidents by some generative AI and using natural languages, this Bits AI can interact with your observability data and give you some next action, for example. We also have LLM observability. So basically in your company, if you have some LLM applications, let's say you are building some prompts, you are building some models, and you want to get the performance of them, compare them, and come up with some KPIs, LLM observability is the full product to help you do that. And finally, which is a core product and a core functionality that we give at Datadog is what we call AI Ops. So AI Ops is artificial intelligence for IT operations. So basically, if you want to identify the root causes of incidents that are coming in your Datadog platform, or help with some monitoring, or detect some anomaly in your metrics and your CPU usage, or some metrics of this sort in your infrastructure, we can provide different functionalities in different places of the Datadog suite. So why is it important to have a platform for all of this? The idea is that we have a lot of engineers at Datadog that are building these products, and we want to scale this innovation and like help them deploy, experiment, and do some AI solutions that could be scalable. So it's a key principle that they can scale quickly with all the data that they have, that is flexible on all the information and the format of this data, that they can build it in a flexible way, and that is consistency. For example, consistency would be a consistency between what they do in experimentation compared to what they do when they want to go to production. And finally, it's auditability. So auditability is important because you want to have the full lineage of your model building and be able to say who did what and why. And focusing on generative AI, because that's the theme of this presentation, there are different ways we can build models. A simple way, or the simplest way, I would say, is to consume pre-trained models. Basically, you have some pre-trained models that are provided by AI providers, and without like modifying the core weights of these models, without having to retrain, you would do some prompt engineering. That's one technique to consume these trained models. And then to come up with a prompt saying, like, for example, do something or investigate something into your application. Then maybe you want to fine tune to a specific use case. You have some curated data set that are specific for you. Maybe it's a bit labeled, and you want to increase the accuracy. So then you want to fine tune this model. Basically, it's retraining on this curated data and having some techniques such as LoRa for a parameter efficient fine tuning. And finally, maybe you want to have some LLM, like train a full LLM from scratch, which is quite extensive in computation, but it's important if you want to have something that is of higher accuracy and performance. So I wanted to give an example use case for that. Like, for example, incident categorization. Let's say you have some log messages and you want a model to say, this is a security incident, this is performance degradation, this is a network issue, or nothing at all. So focusing on this use case, let's see what we can do through the simple way, which is consuming the pre-trained models. So basically, the first thing you would do is access the AI model. That can be an AI model through API access. You want access to an open source AI model. So that's the first thing you want to check, to shortlist that. And then you start the prompt engineering. So basically building what we call a prompt catalog. It's not only this prompt. So the example is the prompt that I gave you just before, but you can iterate on this a little bit further and like try to fine tune it. And like to be able to iterate is to be able to evaluate. You need to evaluate this prompt to say, this is the one I will go with. So how to evaluate that? Some techniques is just to get another LLM as a judge, but another technique, which is more accurate, is to have some labeled data. That can be costly, like you have a data annotator that needs to label its data and come up with some labeled data. So for example, here it will be the logs with their category. And finally, you will come up with a model and with a selected prompt that you can integrate in your application. So that's for the simplest way, let's say, but what is platform for that? I think it's important that for the access of AI model, we have some sort of a model catalog to be able to query any model and to have access to it. And for like experimenting your prompt, you want maybe an LLM experimentation platform, so tools for that. And finally, for the annotation, you maybe want an annotation tool. So returning to the creep principle that we talked about, scalability, flexibility, consistency, and auditability, how the model catalog fits in this. So model catalog is usually to access these AI models. It will scale if you have a large model storage, some retrieval techniques. It's flexible because it would work with different model formats. It's consistent because for each model, you would have some standardized way of adding some metadata to these models, to version these models. And you can know who accesses it and if there are any compliance controls. That's interesting to have on top of this model catalog. For the LLM experimentation platform, so if we remember, the LLM experimentation platform is there when you have a prompt catalog, plus some evaluation and some scoring. It's important that it's scaled because to handle like large prompt testing, some multiple model and performance benchmarking, and that it can also support various LLM because you want to test maybe many, a lot of different formats of prompts because there could be maybe variables in your prompt. and to be able to have different scoring methods for it, the accuracy, the hallucination, different evaluation metrics that you are interested in. And then you want to log the experiments. You want to be able to reproduce them in any format. And finally, track any change, because the user will be changing, this prompt engineer will be changing the prompts, and you want to track who did what and compare the results. And finally, the annotation tool needs to scale. The annotation tool, you need to create projects of annotation. It will need to have various annotation types data, and to be able to integrate in your ML pipelines of data export and import. And you maybe have some agreement checks, like you have many annotators annotating your data, and you need to be consistent and getting some agreement between them. And then all this annotation you want to track the process, the progress, you want to track the user action, what they did, did they finish the annotation or not? So this is for consuming the pre-trained models and what platform can do for that, part of it. And then if you want to train and fine tune, it's simple. Basically, you have two things. You need still your access to the model, still some annotation data specifically for this use case. And then you want to start training, fine tuning, evaluating, and then deploying your model. So here you would have maybe some data scientists or applied scientists doing the experimentation, and an ML engineers to put everything into production. And here it's two platforms to have that connect with each other. That is the training platform and then the deployment platform. Basically, for the training platform, you want to be able to have distributed training. These are large models, so they're going to be very extensive on compute and on memory. So you need to distribute to know when to scale and to know when to downscale. And it can also be flexible for multiple architecture. You want also to reproduce between what you did during experimentation and what you did in production. And finally, track the full lineage of what you experimented, who did what type of data, all of these information about the experiments. And finally, the deployment platform is you finish, you deployed, you evaluated, and now you want to go into production with this model. So it's the same thing. Here are different criteria, like its latency and being able to handle high throughput. And the same thing here, it needs to be integrated in different APIs, microservices. You want to be able to reproduce, to test, to roll back to a different version. And finally, you need to have some access login still. Who are our users who are calling our models? Are there any tracing of the performance or of the action that happened to call this LLM model, whether it has been fine-tuned or trained from scratch? So just to finish on this, I think like these key principles are very important. This is what but to have like impact from platform, when you are a platform team and working with AI engineers that are in different product teams, it's important to prioritize these product teams. So to be a product-driven AI platform, basically, ensure adoption, ensure that there are measurable outcomes. And finally, and specifically for LLM, I think it's important that the quality is there, because it's going to be like a user-facing product. So we talked about annotation as an evaluation step, but you can have like human in the loop to be able to say, after even you deployed your model, that it's a feedback, like give a feedback, it's yes or no. So basically, these are also something we need to think about when creating a platform for AI products. So thank you all.